In today's lesson, we're going to be looking at definite and indefinite integrals, which is going to form the foundation of integration, this major topic in calculus. First of all, we're going to build with the absolute basics of integration, and I genuinely cannot start this topic without first talking about differentiating. They are just like brothers, like whatever one does, you can figure out what the other one does because they're like the reverse of each other. So if, let's say I had y is equal x to the 4, if I wanted to find the derivative of this, what you would do is you would bring the power down and then reduce it by 1. Now, integration is the process of getting the derivative and going back to the original, which we also call the primitive. So if I want to figure out how do I go from here back to here, you're going to do the same steps, but the opposite of them. So if I wanted to integrate 4x cubed dx, what you're going to do first is you want to increase the power by 1. Instead of reducing by 1, you increase by 1. And then instead of timesing it by that power, you're going to divide it by that new power. So we're going to divide the whole thing by 4. These 4's cancel out, and then you're going to get x to the 4. And then we usually denote it with a plus c. Now, when you know whether to do a plus c or not is depending on whether it is a indefinite or a definite integral. So let's start off with a definite integral, it's definitely going to give you an answer. And whether something definitely gives you an answer or not is if there are values for your limits. So if the limits are from 2 to 0, or if the limits are from 5 to 3. Because what these limits are going to do later is once you integrate it, you're actually going to substitute in these limits. You essentially just plug in the upper limit minus plugging in the lower limit. And then it just gives you like this evaluated number. That's why I like to think of it as being definite, because it definitely gives you a value. A indefinite integral is not definite, and these are the ones where you're just integrating and there's no limits. So that means your final answer is going to be your integrated form and then plus c. Plus c because it can be basically any constant. So we just generalize it and write plus c. Okay, now that's the basics. Let's just get into integrating. So first it says, find the indefinite integral of this form. So we have 3 separate terms and they're all in this single integral. You just need to integrate them individually. So first of all, if I integrate 4x squared, you're going to increase the power by 1 divided by that new power. Easy. And then you keep going. You write the same thing, increase it by 1 divided by that new power. How about if you have a 3? Well, if you think about the derivative, if you have y is equal to 3x, when you differentiate it, you drop the x and you get a 3. So if integrating, if you have a constant, to go back to the original, you add the x. So anytime you have a constant here, we just chuck an x in front. Okay, now is that fully simplified? Yes, it is. So I'm just going to write plus c, and that is my indefinite integral. Lovely. Next, question 2. Evaluate the definite integral from 0 to 1. So it's a definite integral because we have limits here. So that means once you integrate this, you're going to sub in the upper and lower limit, and then you're going to end up with just a number. So if I want to integrate 1 to 0 of the cube root of x squared dx, I want you to have the same instinct that you have when you want to differentiate something that looks like this. Well, I tell my students that anytime you have a surd or a x on the denominator, you want to change it back into an index form. So just as a recap, if you have a to the power of m on n, then this fractional power can also be written as a surd. So you have a square root of a, whatever is at the top goes on the inside, whatever is on the bottom goes on the outside. And have a really funny but also sad way of memorizing this. So, back in the, class system, very hierarchical system that we used to live in, whoever was on top sleeps on the inside, whoever's on the bottom sleeps on the outside. Yeah, so cruel, but you know what? It works with my students, so it might work with you guys too. All right, so now what we're going to do is I'm going to first rewrite it in index form. So whoever sleeps inside is on the top, on the outside goes on the bottom. And then now it is ready to be integrated. So careful because we're dealing with fractions. So what you're going to do is you're going to increase this power by 1. And before you touch your calculator, get used to adding fractions mentally. So if I just add 1 like this, you're going to be like, oh, I can't really add it because I don't have the same denominator. So instead, always add whatever's on the denominator over itself. And that immediately gives you 5 on 3. And now you can write divided by 5 on 3, but no teacher ever wants you to leave your answer as a fraction in a fraction. You see he got this smaller fraction in this bigger fraction. So what I get my students to do is you kind of take the reciprocal of that thing you're dividing. So if normally you have a 5 at the top of the fraction, it's going to go on the bottom. And if normally you have a 3 on the bottom, it's going to go at the top. So it's like the reciprocal of the new power. Now, since this is a definite integral, meaning there's numbers here, I'm going to write this with square brackets, and then the limits go on the right-hand side. And this just means I'm going to sub this in. So now if we plug it in, we're going to get 3 times 1 to the power of 5 on 3 on 5 minus 3 times 0 to the power of 5 on 3 on 5. This goes to 0. Anything times 0 goes to 0. This whole thing becomes a 1. So then you're just left with 3 on 5. All right. Okay, question 3. Find the indefinite integral of this. So if you look at this integral, the first thing hopefully you should notice is that x is on the bottom. So using the negative index law, bring it back up. So just to recap, the negative index law says that if you have any base to the power of negative m, then you can actually rewrite this as 1 over a to the power of m. So if I were to rewrite this, we're going to get 5x to the power of negative 4 dx. So now if I want to integrate this, we're going to increase this power by 1. If I increase this by 1, be careful, it's becoming more positive. So it's going to become 5x to the power of negative 3. And then you divide it by that new power. Okay. And then just get the hang of bringing the negative that is only on the denominator, just bring it in front of the whole fraction. They mean the same thing. So just to recap, if I have 1 divided by negative 2, where the negative looks like it's only in front of the 2, that is the exact same thing as negative a half, where negative is in front of the whole fraction. Same thing, if I have negative 1 divided by 2, where the negative isn't only in front of the 1, it's the same thing as negative a half. So generally, just always try to leave it in the form where the negative is in front of the entire thing. And while I'm at it, I'm going to bring x back down to the denominator. So the general rule of thumb is leave your final result, your integrated result, in the same form as the original. So if you had an x to the 4, then you should have x to the 3 on the bottom. Lovely. Question 4. Evaluate the definite integral from 0 to 3 of this guy over here. So the first thing you should notice is I have a product of two things. Now, there is such a thing as product rule, but that's only for differentiating. There is no product rule, no quotient rule for integration. So instead of thinking, I'm going to use product rule, think about, can I write this in a way that is integratable? And in this case, if you expand it, you can integrate the individual expanded bits. So this is going to then become, let me bring this over here, the integral from 3 to 0 of 2x squared plus x plus 4x plus 2. And then just quickly collect the like terms before you integrate it. 2x squared plus 5x plus 2. Okay, so now it's ready to be integrated. We're going to get 2x cubed on 3 plus 5x squared on 2 plus 2x. And then we're going to sub in our limits. So now if we plug in our limits, we're going to plug in the upper limit first. So that's 2x cubed on 3 plus 5 times 3 squared on 2 plus 2 times 3. And you know what's so good is when we plug in our limit for 0, plugging in 0 into here is just going to make everything go to 0. So I'm just going to write minus 0. Now be careful when you do this because not always. Having a limit of 0 doesn't always give you a 0 result. But since each of these numbers are timesing to the x, it will. So now I just need to plug it in the calculator. Okay, we get 93 on 2. Beautiful. Next, question 5. All right, find the indefinite integral of something that looks like this. Okay, now, right now, we have something inside something. So your brain might be saying, oh, use chain rule. Now there is actually a reverse chain rule in integration, but I'll tell you now that we can't use reverse chain rule. If you want to understand why, please watch my video on reverse chain rule. I'll leave it in the description box down below so that you can figure out why this is not allowed. But anyways, we need to think about another way that we can integrate this using the same power rule. Once again, expand it. And we're going to be expanding it by using our perfect square result, which says that if you have a number minus another number squared, then this is going to be equal to a squared minus 2ab plus b squared. Okay, please do not do this. Oh my gosh, if you do this, your teacher will cry. I know this for a fact because I cry when this happens. So what you want to do is, following this rule, you're going to do a squared, which is 1 squared. Now for the middle term, how I like to tell my students to do it is you times these two numbers together. So 1 times x squared is x squared, and then you double it. So it's 2x squared, and it's going to be a minus 2x squared. And then the last term is a positive x to the power of 4. You square the second term. Beautiful. And then now that it's in this form, integrate each individual term. That's going to give you x minus 2x cubed on 3 plus x to the 5 on 5. And this is going to be an indefinite integral, so just write plus c. Beautiful. Question 6. Evaluate the definite integral from -1 to 4. So if I look at this guy over here, I'm just going to rewrite it. Okay. If I look at this guy over here, you're going to be like, ooh, big fraction quotient rule. But remember, quotient rule is not applicable to integration, only differentiation. So I need to think, how am I going to deal with this? And the general rule of thumb is when you have a top-heavy fraction and like where you have 3 terms here and 1 term here, then what you have to do is you have to split this up as 3 individual terms and then you integrate each individual term. So if I split this up, I'm going to rewrite this as 2 divided by the denominator minus x cubed divided by the denominator minus 3x to the 5 divided by the denominator dx. Okay. The reason why this works is I'm essentially just using the very basic fractions principle, which says that if I have 1 over 3 plus 5 over 3, when they have the same denominator, you can combine the top, so that's 6, and then the denominator stays the same. I'm actually doing this, but I'm doing it from this way and then splitting it up like that. Okay, so now I just need to simplify it and then integrate them. So it's going to be a lot of work to get it into the form where it is integratable, but once it is, it's boom, same thing, easy as. So first of all, I have 2 over 3 x squared. Anytime you see x on the denominator, bring that guy up. So we end up with 2 over 3 x to the power of -2. And then for the next portion, we're going to cancel some x's out. So I'm going to cancel out 2 x's. We're left with 1 x at the top. So that's -1/3 x. And then I'm going to cancel out 2 here. We're left with 3. Oh, and these 3's cancel. So we're just left with minus x cubed. Okay, beautiful. And now that it's in this integratable form, we can go ahead and integrate it. So we get 2 over 3 times, when I increase this x by 1, we get x to the power of -1 divided by -1 like this. And then next, if I increase this x by 1, we get x squared divided by 2. And then this increases to 4 divided by 4. And then now I just need to clean this up a little bit. If I have 2 on 3 times -1 down there, we get -2 on 3, and I'm going to write x on the denominator, so with a positive power instead. And then now we're going to have -1 over 6x squared. So how about we write it as a singular fraction, -x squared on 6, and then this is just -x to the 4 on 4 plus c. Oh no, it has limits, so I actually can't do that. The limits are from 4 to -1, so we're going to do the little square bracket business and sub it in. By the way, my little trick for doing this is do not put the entire thing in the calculator. You're going to make it so that it's very prone to making a mistake. So what I do to be efficient as well is I put in the first portion in the calculator. So if I put that in, we get -401 over 6. And then So we have minus, and then I'm going to put this portion, just what's in the bracket in the calculator, but you don't clear it and do it again. You backspace and you replace all of the 4s, because the upper limit is 4. Replace all the 4s in your calculator with -1. And just make sure that it's in brackets as well, because that negative is a little tricky. Okay, so we get +1/4. So now if I put this in the calculator, we are going to get -805/12. Now, I know what you're thinking, because I can read minds, but I know you're thinking, why is it negative? Now, you can absolutely have negative integrals. What it essentially just means is that if you were to sketch your curve from 4 to -1, a larger proportion of it should be underneath the x-axis. So that's it, that's all it means. If you were to find area, then what you do is you just make sure that whatever portion is underneath the x-axis, you just chuck absolute values on it to force it to be positive. But negative integrals are allowed. Okay, lucky last question. Find the indefinite integral, the integral of x root x dx. Okay, now once again, you might be thinking, product rule, but no, we don't do product rule because no such thing. Instead, what I'm gonna do is I'm gonna have the instinct to change the square root of x into x to the power of 1/2. And then when I look at these two, we can just use index laws. They have the same base multiplying each other. If you combine it, you add the powers. So the new power is 3/2. And then now integrate it as usual, x to the power of 5/2. When you divide by a fraction, swap it. So 5 is usually at the top, chuck it down. 2 goes to the top, plus c. And you know what I should do is I'm going to change it back into a surd form. So that becomes 2 square root of x to the power of 5 all over 5 plus c. Huzzah! And that is it. Hopefully you are absolutely ready to smash your homework and smash the exam. If there is any topic you guys want me to go through, please let me know in the comments. I'd love to help you, especially during this busy exam period. Thank you guys, and I'll see you in the next video. Bye!